Hello everyone, let us continue with our discussion on linear equations. Today we will have a look at some of the shortcuts that we have. So by shortcut I mean by just looking at a pair of linear equations, by just comparing the coefficients for these pair of linear equations, we can reach to the conclusion about how the solution is going to be. Whether the pair of linear equations will have just one solution, that is, it is consistent, or it will have no solution, or it will have infinitely many distinct solutions. So just by comparing the ratios, we will be able to reach at that conclusions. So the ratios that we'll compare are, the first one is the ratios for the coefficient of x, a1 and a2. The second ratio will be b1 by b2, and the third ratio will be c1 by c2. So let us quickly look back at the examples that we solved in the last lecture. Okay, so let us first have a look at the first example that we had solved in our previous lectures. The first equation that we had was x minus 2y is equal to 0, and the second equation was 3x plus 4y minus 20 equal to 0. Let us have a look at the ratios. a1 by a2 is 1 by 3. For b1 by b2 we have minus 2 divided by 4, minus 2 divided by 4, which will be equal to minus 1 by 2. And for the constants we have, in here we have 0, so 0 divided by minus 20 will be 0. So the observation that we can make here is the ratio a1 by a2 is not equal to b1 by b2. And in this case, we had seen that the two straight lines that we had were intersecting, and we had found a common solution for 2. And this value of x and y would satisfy both these pair of linear equations. Okay, let us have a look at the second example that we had last time. The first linear equation, 2x plus 3y minus 9 equal to 0, and the second, 4x plus 6y minus 18 equal to 0. So in this case, if we have a look at the ratios, a1 by a2, 2 by 4 is 1 by 2, 3 by 6 is 1 by 2, and minus 9 by minus 18 is 1 by 2. So the observation that we can make here is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So all the three ratios are same, and the solution that we had in this case was both these lines were coincident, and they had infinitely many distinct solutions to it. And in our third example, we had two equations for the railway lines. The first one was x plus 2y minus 4 is equal to 0. The second one was 2x plus 4y minus 12 equal to 0. In this case, if we look at the ratios, a1 by a2, 1 by 2, b1 by b2, 2 by 4, which is equal to 1 by 2, and c1 by c2 is minus 4 by minus 12, which is equal to 1 by 3. So in this case, the ratios a1 by a2 is equal to b1 by b2, but this ratio is not equal to c1 by c2. And in this case, we had found out that the two lines are parallel and there is no common solution for it. So what do we see from these above three examples is that there is some relations between how these ratios are in the pair of linear equations and what are the corresponding solutions for it. In the first case, where the coefficient of x, a1 by a2, is not equal to b1 by b2, then we have intersecting lines and one solution, one consistent solution. In the second case, where all the three ratios are equal, we have coincident lines and we have many solutions, infinitely many distinct solutions. And in the third case, where we have the x coefficient ratios, a1 by a2, equal to y coefficient ratios b1 by b2, but then this is not equal to the constant ratio c1 by c2, and in this case we had parallel lines and there was no common solution for it. So with just these facts, with just comparing these ratios, we can, right at the very start, when we have a look at the linear equation, we can straight away compare these ratios and then conclude that whether it will have a solution, or it will have many infinite solutions, or it will have no solution at all. So this is same thing what we discussed and formally written in the table. And yeah, so a pair of linear equations will be intersecting if a1 by a2 will not be equal to b1 by b2. They will be coincident if all the three ratios a1 by a2 equal to b1 by b2 is equal to c1 by c2, and they will be parallel if a1 by a2 is equal to b1 by b2 and this ratio is not equal to c1 by c2. Now, why these things happen? Why, if the ratios are equal, they are coincident? Why, if these ratios are equal but this one is not equal, then we have parallel lines? And why, if these ratios are not equal, they are intersecting? These concepts will come later when we will go through when we will understand the slope of lines and the concept of x-intercept and y-intercept, but those are for later. So right now you can just keep these facts in your mind, and then as you practice with many different examples, this will just be in your thought process. And the very first thing that you will do whenever you look at a pair of linear equations is you directly compare their ratios, and then you can directly reach to a conclusion whether it will have a solution or not, and then you will decide whether to proceed further or not. Let us have a look at few more examples. Okay, so we have two linear equations, x plus 3y minus 6 is equal to 0, 2x minus 3y minus 12 equal to 0. So the very first thing that we will do is have a look at the ratio a1 by a2. So it is 1 by 2, a1 by e2, 1 by 2. What do we have? b1 by b2 is 3 by minus 3, which is equal to minus 1. Therefore, we have a1 by a2 is not equal to b1 by b2. So we can immediately conclude from this that the lines will be intersecting and there will be one solution for it. And now we can graphically solve for the solution. So as we had discussed earlier, in order to plot the first equation, we have x and y as 6 minus x by 3. So if we take 2 points, x as 0, we get 6 minus 0 by 3, 2. So this is our first point, 0, 2. And if we take x as 6, then we get y as 0. So this is our second point, 6, 0. Now you just join these 2 points and then extend it, and you have your first straight line. And for equation 2, you have x, y, and y as 2x minus 12 by 3. So x 0 minus 4. So this is the first point, 0 minus 4, and 3 minus 2 is somewhere here. So you get these 2 points, and then you just extend. If you just extend these 2 points, then you'll get the second straight line. And here you can find the intersecting point will be 6, 0. So yeah, so this is our solution for this equation. Quickly, you can check 6 plus 0 minus 6. So 6 minus 6 is 0. It satisfies equation 1. And for equation 2, 2, 6, 12 minus 0, 12 minus 12 is 0. So it satisfies both of these equations. And we have intersecting lines, one solution, consistent pair of linear equation. So yeah, so we started with comparing the ratios. The ratios were not equal, and we can find that these are consistent pair of linear equation. Let us have a look at another example. So the first equation we have is 5x minus 8y plus 1 equal to 0. The second one we have is 3x minus 24y by 5 plus 3 by 5 is equal to 0. So first let us have a look at the ratios. a1 by a2 is 5 by 3 and b1 by b2 is minus 8 by minus 24 by 5. So we will have this gone 3, this goes upper, so we will have 5 by 3. And so we have a1 by a2 is equal to b1 by b2. And now if we also have a look at c1 by c2, we have 1 by 3 by 5, which is also equal to 5 by 3. So we have this case, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. And from this we can directly conclude that this pair of linear equations represent some kind of coincident lines, and they will have infinitely many solutions. You can go ahead and try to plot the graph, find some points and then try to plot the graph, and you'll find that they indeed form a graphical, they indeed form a coincident lines, and there will be infinitely many solutions. In fact, if you just have a close look at the equation, and if you multiply equation 2 by 5 by 3, if you multiply this equation by 5 by 3, then what you get is this equation. So 3 will cancel, so you'll get 5x, 5 will get cancelled, you'll get minus 8y, and this will be 1. So indeed, if you just have a look at this equation is just a scaled up version, and this is why we get a coincident pair of lines and infinitely many solutions. So this is a small trick. Instead of going through all this process of plotting the lines and then finding out that they are coincident lines, you can directly at the very first step, you can find out that they are coincident lines. It is a dependent pair of linear equation, and there are infinitely many solutions to it. Let us quickly have a look at another example. So these kinds of examples, they have a lot of words. Basically, these kinds of questions represents the real life situation. Whenever you talk to a friend or someone, they don't tell you anything in equations as y is equal to 2x or y is equal to 4x. They tell you what they experience. So let us have a look at this question. Champa went to a sale to purchase some pants and skirts. When her friends asked her how many of each she had bought, she answered, the number of skirts is 2 less than twice the number of pants purchased. Also, the number of skirts is 4 less than 4 times the number of pants purchased. Help her friends to find how many pants and skirts Champa bought. Okay, so whenever you find these kinds of questions, the very first thing that you need to do is to have a look at what are the variables, what are the things that we need to find. So we need to find how many pants, how many skirts. Okay, so let's say we say number of pants as x and number of skirts as y. Okay, so now we have a representation. So pants we are representing with x and skirts we are representing with y. Now let us just put the words into equation. So the first thing that she said, number of skirts is 2 less than twice the number of pants purchased. So number of skirts, that is y, is equal to 2 less than twice the number of pants. So what is twice the number of pants? 2x. And the number of skirts is 2 less than twice the number of pants. So 2x is twice the number of pants, 2 less than twice the number of pants. So this is what first equation we have. write it in standard form. 2x minus y minus 2 is equal to 0. Equation 1. Now the second thing that she said, also the number of skirts is 4 less than 4 times the number of pants. So number of skirts is 4 less than 4 times the number of pants. So 4 times the number of pants is 4x, and the number of skirts, that is y, is 4 less than 4 times number of pants. So this is our second equation. 4x minus y minus 4 is equal to 0. So yeah, so now we have set up our pair of linear equations, and now we just need to find out the value of x and y, and that will be the number of pants and number of skirts. So first, let us quickly check the ratios. A1 by A2 is 1 by 2, B1 by B2 is equal to minus 1 by minus 1, which is equal to 1. Therefore, A1 by A2 is not equal to B1 by B2. So this implies there will be some kind of intersecting lines with one solutions. So it is worth proceeding ahead. Okay. So if we use our previous knowledge of how we plot lines, so the first equation that we take, x and y is 2x minus 2, so 1 point. If you put x as 2, you get 2, 4, minus 2, 2, x as 0, you get y as minus 2. So the first point is x is 2, 2, so this is your first point. The second point is 0, minus 2, you just join these 2 points, you get your first straight line. For the second straight line, you do the same thing, x, y as 4x minus 4, x is 0, y is minus 4, x is 1, y is 0. So you have these 2 points, 0, minus 4, 1, 0, you join these lines, extend, and you get your second straight line. And you can see that they are intersecting at the point 1, 0. So the answer that you have is x is 1, y is 0. Therefore, the number of pants she bought is 1, and number of skirts Champa got was actually 0. So yeah, so this is how we solve linear equations. And today we learned about comparing these ratios, where in the very beginning we can know if the linear equations has a solution or not, and whether it is worth going ahead to solve to try to solve the linear equations or not. Thank you very much.